To solve this population problem, I'm going to use the equation or the formula y equals a times b to the x, where a is going to equal my initial value, my initial population. Y is going to equal my final population, or at least my final population where the problem ends, and then x, or sometimes I'll often use t there because that just represents the time. And then b is going to be the growth rate, which I'm not going to know when I start the problem, at least in this example. So let's see what we've got, and let's get some of these numbers plugged into my equation. So I can see that I'm beginning with a population, an initial population of 7,500. I can see that the time is 4 hours in this case, and my final population, at least when the problem ends, is this 23,000 cells. So let's go ahead and get those values plugged in so that I can find my growth rate and then write an equation for this, an exponential function for this. So let's go ahead and plug these values in. Like I said, so 23,000 was my y value, my final amount. I began this problem with 7,500 cells. I don't know the growth rate, that's what I'm being asked to find this time, but I know that this growth has happened over the course of 4 hours. So with all those variables plugged in, I should have not too much difficulty finding out what that growth rate is. So I'm going to go ahead and divide both sides by 7,500. And when I do that, I get an answer of about 3,067. Actually, I don't know if that's about or exact. I don't have my calculator in front of me. I'm just checking my notes. And then I get b to the fourth. Well, to get rid of this fourth power, what I'll do is go ahead and take a fourth root of both sides. So again, using a calculator for this, because I wouldn't want to do this by hand, let's take a fourth root. And if you need help finding that button on your calculator, if you have a graphing calculator, look under the math menu and you'll see a button that looks something like this. I believe, oops, that's a Y. And you can use that to get a fourth root or a fifth root or whatever. When I do that, I get an answer of about 1.32. I'll go ahead and round that off. Now, do pay attention to what your book or what the problem is asking you to round to, because in these problems, even a slightly different b value can make a huge impact on your final answer. So I'll go ahead and round to 2 decimal places, and with that, I can now write my equation, going back and plugging in the original 7,500. Times this growth rate I just found of 1.32, and I can raise that to the x power. So I can use this to now find any population anytime afterwards. So that's actually what they're asking me to do in part B here, so let's go ahead and see what they want. They want to now know how many cells can I expect in the same sample if 12 hours have passed. So that's going to be my new x value. Luckily, I have all the other values figured out, so I should be able to just get a calculator out and plug all this in. 7,500 times the 1.32 raised to the 12th power gets me approximately 209,869 cells. I'll round to the nearest cell in this case. And again, double check what your teacher, what the problem asks you to round that b value to, because that can make a very dramatic difference. Even one small decimal place here, if you round to 3 decimal places, I think I tried it and this number comes out like 212,000. So it can become quite a significant difference, so just pay attention to that.